Okay, we will now talk about a very important concept, a very important and interesting concept in wave motion, and that is interference of harmonic waves. What is the meaning of interference of harmonic wave? If two waves exist in a medium, how will the two waves together, what kind of waveform will the two waves together will produce? And that is what we will discuss here. Now let's look at the contraption that I made some time ago using the straws. Now suppose I produce two disturbances. Now if I produce just one disturbance, you can see how that the energy advances. If I produce two disturbances, now watch, I'm going to produce two disturbances, 1, 2. Now look at the vibration of each particle. That means each of these is now subjected to displacements from both disturbances. You understand that? This particle or this straw will be subjected to the disturbance produced here, also disturbance produced on the right side. Now that means energy from both disturbances will reach the same particle. And how will this particle then behave? That is the question of interference. Okay, let's try and understand this a bit more. Suppose this is one particle in a medium. Now it receives energy from one disturbance. You understand when I say disturbance? You see, to create a wave in water, for example, you drop a pebble, and that pebble falling on water creates a disturbance. It sets the particles into vibration, and that energy travels along the surface of water. Now if this particle receives energy from one disturbance and move from the equilibrium position to the upper extreme. Now it receives energy, suppose, from another disturbance also. Now the energy from the first disturbance instructs this particle to move up. Suppose the energy from the other disturbance wants this particle to move down. Then we say these two disturbances are meeting at the same place, completely out of phase. You see, when one disturbance wants this particle to move up, the other one wants it to move down. What is the phase difference between the two disturbances? The phase difference is T/2 or pi. Now when the phase difference is pi, they are completely out of phase. Now what will this particle do? Disturbance 1 wants this particle to move up. Disturbance 2 wants this particle to move down. What will this particle do? It will not move, it will just stay there. That means two waves meeting at a point, if they are completely out of phase, they will cancel each other. They will destroy each other. That means this particle will not vibrate. On the other hand, if the first disturbance wants this particle to move up, the second disturbance also wants this particle to move up, that means those two disturbances are in phase. That means this particle will move a lot up. So when two disturbances meet at a point in phase, their amplitudes will add up, producing a big wave. If they are completely out of phase, their amplitudes will destroy each other, producing no wave. Well, let's now see how I can explain this a little more clearly. That's a concept I want you to understand very well. If two disturbances are created in a medium at the same time, the energy of these disturbances will be propagated through the medium simultaneously. That means each particle will have these two disturbances superimposed on them. You see that? Each particle on the medium will now be subjected to both these disturbances. And that particle then will vibrate depending on whether the disturbances arrived in phase or out of phase. We would assume that the amplitude, frequency and period of the waves generated by both disturbances are the same. The displacement produced by the first wave can be written as y1 equal to a sine kx minus omega t. Suppose this is the equation for the disturbance created by the first wave. Now, a second disturbance a little later means there is a small phase difference there. And how will you represent that? We're going to represent it by that phase angle delta. Suppose a second disturbance which happened a little later. We will represent that as y2 equal to a sine kx minus omega t plus delta, where delta represents the phase difference between the two disturbances. If this delta is 0, that means there is no phase difference. They are in phase, which means you will get a bigger wave. Here, delta is the phase difference between the two waves. Since each particle in the medium will be subjected to both these displacements simultaneously, the actual displacement of a particle will be the sum of the displacement produced by this wave and this wave. In other words, the net displacement of each particle will be the sum of y1 plus y2. You see, if only the first disturbance existed, then the displacement of this particle will be given by y1. If this is the only disturbance, then the displacement will be given by y2. But this particle is now subjected to this disturbance and this disturbance. That means the displacement of this particle will now be y1 plus y2. And what will that be? The net displacement now equal to y1 plus y2. And let's write it that way. Y equal to a sine kx minus omega t plus a sine kx minus omega t plus delta. Now, does your trigonometry allow you to simplify this? Let's go to the other slide and do that. If the two waves are in phase, that means there is no phase difference, then delta will be 0. That means disturbance 1 and disturbance 2 will arrive at this particle in phase. So delta will be 0. What will therefore be the total displacement? Will be a sine kx minus omega t plus a sine kx minus omega t, which is 2a sine kx minus omega t. The displacement of this particle will be twice its normal displacement. Now, this kind of a superposition, one wave superimposing on another, so that they are in phase, is actually called a constructive interference. What's the meaning of constructive interference? Well, it adds up. Now, if two equal waves interfere in phase, the resultant wave has twice the amplitude. You see, in place of A, you have 2A. When the interference is constructive, the resultant wave has twice the amplitude. Now, look at this. One wave added to another wave, they are in phase. How do you know they are in phase? The crest of one wave falls on the crest of the other. The trough of one wave falls on the trough of the other. This is how waves superimpose in phase. that produces a bigger wave. Look at the bigger wave, a bigger amplitude, and this is called constructive interference. When two waves meet in phase, you have a constructive interference. Okay, on the other hand, if delta equal to pi, what does that mean, delta equal to pi? The phase difference is pi, means when one disturbance wants the particle to move up, the other disturbance wants it to move down. That means due to one disturbance, if the particle has to be on a crest, due to the other disturbance, it has to be on a trough. You see, the crest of one wave falls on the trough of the other wave. What will happen? The particle will not move anywhere. It will not be on the crest of one wave, nor will it be on the trough of the other. It will simply remain in the equilibrium position. So this will be y equal to a sine kx minus omega t plus a sine kx minus omega t plus pi. If you simplify this in trigonometry, it will become, I'm not going to take time to do that, but a sine kx minus omega t plus pi is the same as negative a sine kx minus omega t. And you can see this is a sine kx minus omega t minus a sine kx minus omega t, that's 0. The resultant amplitude when the two waves meet completely out of phase is 0. If two equal waves interfere completely out of phase, the resultant amplitude is 0 everywhere in the medium. That means there is no wave. The displacement created by one wave will be cancelled by the displacement created by the other wave. Particles in the medium will simply stay at rest. Now look at the representation here. One wave, if a particle here is supposed to be on a trough due to wave 1, it is supposed to be on the crest of wave 2. The trough of one wave falls on the crest of the other, and the crest of the first wave falls on the trough of the other. These two waves are completely out of phase. What is the phase difference between these two? It's pi. What is the result? There is no displacement. And what do you call such an interference? It is called a destructive interference. So interference can be constructive or destructive. If delta is other than 0, you see, if delta is 0, you have a constructive interference. If delta is pi, you have a destructive interference. In practice, the value of delta can be anywhere between 0 and pi. So you can have a situation in between. Then the total displacement of each particle will depend on the value of delta. So it will be therefore y equal to a sine kx minus omega t plus a sine kx minus omega t plus delta. Now in trigonometry, there is an equation that will help you to simplify this. We will use the trigonometric identity for sine A plus sine B. If you notice, A stands for this quantity, kx minus omega t, and B stands for this quantity, kx minus omega t plus delta. Now, does anybody remember that trigonometric identity for sine A plus sine B? Well, this is that identity. Sine A plus sine B is 2 cos A minus B divided by 2, or 1/2 times A minus B times sine 1/2 times A plus B.